Hi, my name is Jamie DeYoung, and I created this video, Integration Techniques, a Revision Question, for the course MAT136 at the University of Toronto. So the goal of this video is to give you a practice question based on Chapter 7, and I'm not going to specify what techniques you should look at for this, because part of the point is to try and figure out what technique can be best applied. So before you continue watching the video, I'd like you to have a go at this question. So the one we're looking at here is the integral of sine of the natural log of x. And so I suggest that you pause the video and have a go at this first. And once you've had a go, then you can continue and we'll be going through it. So the first question that we ask is what techniques might apply to this? Now, in Chapter 7, you looked at a strategy for integration, what sort of things to look for. So we'll briefly look at that list. So one thing we ask is, can we simplify it? Unfortunately, in this case, the answer is no. This isn't a rational function, so partial fractions isn't going to be helpful here. There's no square root involved, so none of the techniques involving square roots are going to be applicable. There's no product here. It's sine of the natural log of x, so there's certainly no product involving a polynomial that jumps out at us as integration by parts. There's no obvious substitution, and by obvious I mean a substitution where the derivative also appears. There's a natural log of x here, but 1 over x, which is the derivative, isn't anywhere in this function. And although it does involve a trig function, this isn't one of the types of trig integrals that we looked at earlier in the course. So unfortunately, we've kind of exhausted our list of typical techniques that we could spot. So that means we're going to have to try something a little bit more tricky. So there's a couple of options. One is that we try integration by parts anyway. We only have one factor, but we can pick the invisible one as our other factor, and therefore attempt integration by parts. And the other thing we could do is make a substitution for natural log of x. It's not one of the substitutions where we can see the derivative, but we could substitute anyway and see if it's helpful. So we're going to go through both of these techniques, and we'll start with the second one, a substitution for natural log of x. So we'll call the natural log of x t, and that means x is e to the power t, which means dx is e to the power t dt. So we can replace dx with e to the t dt. And sine of natural log of x becomes sine of t. So we get the integral of sine of t e to the power t. Now, hopefully this looks somewhat familiar to you. We looked at recursive integration by parts earlier in the course, and this was one of the types of integrals that we used that on, because trig functions and exponential functions tend to differentiate to eventually come back to themselves. So we'll have a go at integration by parts now. So we've got sine of t and e to the t. We'll call the first one u and the second one dv. So u is sine, which means du is cos. dv is e to the power t dt, which means v is e to the power t. And we can apply integration by parts. We get uv sine of t e to the power t minus the integral of v du, which is cos t e to the power t. Now, this looks fairly similar. Cos of t e to the power t isn't really any easier to integrate than sine of t e to the power t, so we're going to have to use integration by parts again. We'll pick u to be cosine this time, and dv is still e to the power t dt. So our du is negative sine, and v is e to the power t. So this is what we had before, and now we apply integration by parts, and we get uv, which is cos of t e to the t, minus the integral of v du, which is negative sine t e to the power t. And now you'll note that our right-hand term is the same as the integral we started with, and so we can add that, shift it to the other side. So we'll get 2 times the integral of sine of t e to the t is sine of t e to the t minus cos t e to the t. And now we divide by 2, and that gives us the integral that we were looking for in terms of t. There's one thing left to do, which is substitute back. So at the beginning we said let t equal natural log of x, so now we'll replace these t's with the natural log of x, and this is the expression we get. We take x times sine of natural log of x minus x times cos of natural log of x, and we divide the whole thing by 2. So that's one of the techniques we came up with. We said we could apply a substitution even though we don't see the derivative in there, and hopefully it will give us something a little bit nicer, which it did. It gave us something that looked like the sort of form we expect for integration by parts when done recursively. Now, the other thing we said we could do is try integration by parts in the first place, with the second factor being 1. So let's have a go at that now. That means one of our factors, u, is sine of natural log of x, and we'll pick that to be u because we don't know how to integrate it. If we did, we'd be done. So that means du is cos of natural log of x divided by x, and then dv is our factor of 1, so v is x. And when we apply integration by parts, we get uv, which is x sine of natural log of x, minus the integral of v du. So the 1 over x in the du cancels with the x that is equal to v, and we're left with the integral of cosine of natural log of x, which looks fairly similar to the integral we started with, and we can apply integration by parts again. And hopefully this looks kind of familiar to you because it's relatively similar to what we just did in method 1. So this time we'll pick u to be cos of natural log of x, and then dv will be our factor of 1. So du is negative sine of natural log of x divided by x, and v is x. So this is what we had before, and now we apply integration by parts. uv gives x cos of natural log of x, and the integral of v du, again the x and 1 over x cancel out, and we're left with the integral of sine of natural log of x, which is what we started with. So much like before, we can add it to the other side and then divide by 2. So we get x sine of natural log of x minus x cos of natural log of x divided by 2, which thankfully is exactly the same expression that we got when we did it using method 1. So in this case, either of those methods will work out. There wasn't any particularly obvious method when we first glanced at it, but we said we could try integration by parts anyway, we could try a substitution anyway, and in this case both of them worked and they gave exactly the same form of the answer. So either one is fine. Okay, so I'm going to leave you with an exercise that's sort of along the same kind of lines. So we have the integral of sine of the cube root of x. And I've got the answer here so that you can check once you're done whether you did it correctly. If you have any questions, feel free to come and talk to me in my office hours or ask questions on Piazza. Thank you.